In this last video, what I want to do is I want to show you one of the solutions, or one of the things that many countries try to use to improve outcomes in the public goods story, and this is patents and copyright. And these are solutions that don't really work, and I'll show you the theory why they can't really work properly today. And the reason that they don't work is, in part, the externality that's basic to public goods of all kinds. The reason they don't work is because patents grant a type of monopoly, and that allows the patent holder to become a price setter. And when the patent holder becomes a price setter, what effectively happens is it becomes much more lucrative for the patent holder to take your money away than it is for them to produce the public good, or at least there's that trade-off. And so I want to show you how those two things interact, and I'm going to do it with just using the outcome of the voluntary contribution game as an anchor to show what's going on. And I'm going to award a patent to one of the two players, and let that player go ahead and do what you do when you have patents, and we'll see what the equilibrium outcome looks like in this case.
The way patents work is that you send a lawyer to the patent office and you apply for the patent, and if you're the first one who did it, you get the patent. And so patents really have nothing to do anymore with somebody discovering a technology or anything like that. They're just legal devices that give people control over the production of a certain good. And so in this case, let's just assume that player 2 managed to go to the patent office first and got the patent for the production of our public good. This is the events that we've produced in the club, and player 2 is the only one that's allowed to produce those things. Now, the reason that she wants to do that is, of course, is because she can now charge player 1 for the events that are produced, and so she gets to not only charge and get money from player 1 for doing that, but nobody's allowed to compete with her, so she can set any price that she likes for the public good. And if she once she chooses a price, then there's really nothing that player 1 can do about it. And this is really the trade-off with patents. The idea behind giving a patent is that when you do that, the player who gets the patent has some incentive to produce the good, because she knows if she produces the good, she can get money from the other person, and that, to some degree, rectifies the problem that we talked about previously, which is that when you work on the public good, you don't gain any advantage from the person who benefits from the public good, and so you tend to underproduce. And so the logic of patents is to try and give player 2 an incentive to produce the stuff that's actually good for player 1. The trouble with this is that when she gets to choose the price for player 2, it gives her an opportunity to make money from something other than producing the public good, which is to try and extract the surplus that player 1 gets from consumption of the public good. And this oftentimes completely overrides the advantages of giving her extra incentive to produce the public goods. We'll see that here in these slides, but the basic point of these slides is just to illustrate the trade-off that's involved with patents, and to show you that they're not really a solution to the public goods problem at all. And that's one reason why it is that when companies try to defend their patents or their copyright, they don't talk about the benefits of patents and copyright, because they don't really create that many. They talk about the problems that occur when you don't have any patents. And so let's just go through the story to see how that works. So the first thing to recognize is that player 2 is going to set a price for this public good. And once she sets the price for this public good, then player 1 has no choice at all. So here's player 1. Player 1 has some endowment of time that he would like to spend for the public good. And what he has to do is he has to give up time at a rate that's specified by player 2. And I'll talk about the price of the public good here, and if you like to think of the price as being the price for good X, that's okay. The price for the public good would just be 1 over the price of X. So you can do that if you like. So player 2 sets the price, and player 2 says, well, if you want the public good, what you're going to have to do is to give up this amount of your leisure time, and in exchange for that, I'm going to determine how much public good you get. It's going to be this amount up here. And how that's actually accomplished doesn't really matter, because player 2 is earning some revenue from that public good now, and that's supposed to help her recoup the benefits of the work that she does. Now, of course, given that price, what player 1 does is he just chooses the best combination of public and private good that's available to him. And he acts as a price taker. There's nothing he can do about it, because that's the law. So he picks the best bundle that he can, and that's just the one of the tangency, as it has always been. Now, the next part of the story just is to recognize what happens when player 2 varies the price of the public good, because remember that for her to figure out what price she should set, she needs to figure out what player 1 will do in response to her various prices. And so, for example, if she raises the price of the public good, well, what does that mean? If you compare these two slides, here, if you want to spend all of your time working on the public good, or you want to donate all your time to try and get that, you get a lot of public good out of that because of the price that player 2 has set, because of the fact that the player 2 has set the price relatively low. But here, player 2 has raised the price of the public good, so you spend the same amount of time, you're going to get a lot less of the public good. And now that's now up to player 2 to decide exactly how that should work. So we can actually do this for all the possible prices that player 2 can set, and for each different price, player 1 will choose a different bundle. So here's the very cheap price. Player 1 chooses a lot of the public good. Player 2 starts raising the price. Player 1 starts choosing a little bit less of the public good, less still of the public good. And if we wanted to, what we could do is we could collect together all of the points where the indifference curve of consumer 1 was tangent to some budget line going through his endowment. And if we did this for all of the possible prices, that would be all the different slopes. We would trace out a curve. And this is a curve you've actually seen before. It's something that we called the offer curve when we were talking about private goods last week. So there's the offer curve, and at every point on that offer curve, if you draw a straight line from a point on the offer curve back to the origin here, omega 1, what you'll find is that there's an indifference curve tangent to that straight line exactly at the offer curve, just as there are for these points here. And so what that offer curve represents for player 2 is the options that she has available, because she varies the price. She can use this offer curve to trace out how it'll affect player 1's demand for the public good. Now, of course, player 1's demand for the public good is of some interest to her, because the combination of her consumption of leisure and player 1's consumption of leisure together determines what her payoff is, as we saw in the last lecture. And so let me just strip all of that stuff out of there except for the offer curve. And so from 2's perspective, 2 is choosing between player 1's contribution to the public good and the total amount of public good that's produced. She can set any price she likes and induce player 1 to do the corresponding contribution, and then add her own contribution as she likes to produce the public good. And so this locus that represents the offer curve from player 1, remember how I got it up here, this locus that represents the offer curve for player 1 is like 2's budget set. And her indifference curves now, as we described last time, are indifference curves that trace out pairs of person 1's contribution, or person 1's leisure time, and total output of the public good, to which 2 is indifferent. And how is she indifferent? Well, she's indifferent in the sense that if you actually wrote down one of these indifference curves, let me just do it here. There's an indifference curve for player 2. As she moves along this curve, what happens? Well, here player 1 gets a little more leisure time for himself. The output of the public good goes down, and how does that benefit player 2? Well, player 2 is making up the difference. She's relaxing a little bit more, and because she gets a little more leisure time on her own, she's indifferent between a point out here and a point out here. And any point along this curve, the trade-off is exactly like that. And the point of this particular indifference curve is that's the one at the tangency with the offer curve of player 1. And so this means that this is the point where player 2 gets her highest payoff. She wants to go down here where player 1 doesn't get much leisure time. This is the point where player 2 gets her highest payoff by setting a price and tracking out where it is that player 1 goes on this offer curve. And so player 2 would like to set the price that goes right through that tangency, like that. And if she did that, player 1 would reply on his offer curve, and then she would make up the difference to produce the public good that corresponds with that point there. Now, that's what's going to happen once player 2 gets the patent for the public good. And at various points in these lectures, I've said that these patents don't really work in the sense that they don't resolve the problem associated with public goods. And if you'd like to see why that is, all we really have to do is to draw in player 1's indifference curve at this point on the offer curve. And that's the highest one in the budget set that player 1 faces. And you can see that because of the shape of the offer curve and the tangency for player 2, that the indifference curves for player 1 and player 2 still cross each other. And so despite the fact that we've got tangents, there's still something that we could do that would make both players better off, and that would be to move up into this lens-shaped area up here. Now, one of the things to notice about this particular solution, the fact that it's not Pareto optimal, because we